Ever wondered why convolutional neural networks are a big deal in the realm of deep learning? They're not just some fancy buzzwords, but the key drivers behind our ability to effortlessly recognize images and videos. Imagine a world where your Facebook couldn't tag you in a photo, or your car couldn't detect a pedestrian. That's a world without convolutional neural networks. They've revolutionized deep learning, bringing us closer to creating machines that can see. So, are you intrigued to understand how these networks function? Stay tuned. Convolutional neural networks, abbreviated as CNNs, are not as complex as they may initially seem. These powerful tools of deep learning are essentially inspired by the workings of our very own brains. Like the human brain, CNNs are comprised of neurons, tiny entities that individually process pieces of information. Imagine neurons as workers in a factory assembly line. Each worker has a specific task, contributing to the larger goal of manufacturing a product. Similarly, in a CNN, each neuron processes a small bit of data, contributing to the bigger picture of recognizing and interpreting the data. Now let's talk about the hierarchical pattern in CNNs. This is akin to how we humans learn new things. For instance, when we learn a new language, we don't start by reading novels. We begin with the basics, like alphabets and grammar rules. Once we've mastered these, we move on to sentences, then paragraphs, and eventually full-length novels. This is precisely how a CNN works. It starts by learning simple patterns, gradually moving up to complex ones. But why is this hierarchy crucial? Well, it allows CNNs to break down complicated problems into smaller, manageable tasks. It enables them to learn from the simple to the complex, just as we do, making them incredibly efficient and versatile. Now that we've laid the foundation, let's dive into the workings of these networks. Peeling back the layers of convolutional neural networks, let's explore how they operate. At the heart of a convolutional neural network, or CNN, lies a series of layers, each with a specific function designed to recognize and categorize complex patterns within data, particularly images. The first layer is the input layer, where the CNN receives the raw pixel data of the image. This is the starting point, the gateway to the intricate process of pattern recognition. Next up, we have the convolutional layer. This layer uses a mathematical operation called convolution to scan the input image with small, square filters. These filters or kernels move across the image, processing small chunks at a time. The result? A set of feature maps, which are essentially filtered versions of the original image highlighting certain features. But it doesn't stop there. Enter the ReLU, or rectified linear unit layer. This layer applies a simple yet crucial function that introduces nonlinearity into the model. It replaces all negative pixel values in the feature map with 0, allowing the model to handle complex patterns. Then comes the pooling layer, also known as a downsampling layer. This layer reduces the spatial size of the feature maps, making the model less sensitive to the location of features in the image and more computationally efficient. Finally, we have the fully connected layer. This layer takes the output of the previous layers and flattens it into a single, long vector. This vector is fed into a neural network, which uses it to classify the image based on the features detected. Throughout this process, feature maps play a pivotal role. They are the manifestation of the neural network's learning. As the network trains, it learns to create feature maps that highlight the most important elements of the image for classification, be it the edges, textures, or shapes. With these steps, CNNs are able to identify complex patterns and make accurate predictions. They truly are a marvel of modern machine learning, turning raw data into meaningful information with a series of intricate yet beautifully coordinated steps. Convolutional neural networks are truly a marvel in deep learning, aren't they? They have revolutionized how we perceive and process visual data. Imagine being able to extract the essence of an image, to understand its content and context. And all of this, thanks to the layered architecture of a CNN. The importance of these networks cannot be overstated. They are the backbone of many modern AI applications, providing an exceptional ability to analyze visual data, which is a feat not possible with traditional neural networks. Remember, the magic of convolutional neural networks lies in their ability to automatically and adaptively learn spatial hierarchies of features. This is done through a step-by-step process involving convolution, pooling, and fully connected layers, each playing a crucial role in the functionality of the network. And the result? Unparalleled advancements in image and video recognition tasks. So there you have it, a quick but comprehensive understanding of convolutional neural networks. Until next time, keep exploring the fascinating world of deep learning.